Alrighty, hello everybody, and welcome to the first video. We're just going to be covering the beginning of the first week of engineering economics. So basically, how our professor kind of posted the lecture slides, as he said to us, it's going to be like, he's going to post like a whole bunch. So it's going to be like 4 lectures or 2 weeks or so worth of slides and stuff, and he's just going to kind of stop and start. I've taken the initiative upon myself to kind of break it up into relevant kind of areas. So today I'm going to be going over the first week, which probably won't be that content heavy because the first lecture, a lot of it is just kind of like course overview and stuff. So basically today we're going to cover, I'm calling it lecture 1, and it's going to be the intro to economics. We're also going to cover micro and macro economics. So engineering economics at the core, it's methods of simplifying and comparing alternative methods for something. So if you have, like, the biggest example is going to be energy, because our professor is a big energy guy, so he talks about it a lot. It's like, okay, what if we're going to break down what's going to be the better decision to choose a nuclear plant or a solar plant. So how are we going to break it down in a way that we're able to just look at the numbers and say, okay, this one's going to be the best for our situation. So basically what you're doing is you're leveling the playing field for all these numbers, which could be like kind of seem obscure and not really comparable. It's basically just putting them all on a level playing field so that you can actually compare these numbers. And so one example of this is a levelized cost of electricity. So what it does is you measure the energy produced in a lifespan and you compare that to the cost. So it's going to be, when you look at it, it's going to be dollars per megawatt hour. So an example of when you would actually use this is when you're comparing the CANDU nuclear power plant to a U.S. nuclear power plant. It's like, well, you can't really do it just like that because the CANDU's output is 900 megawatt hours when the U.S. nuclear is around somewhere between 1.1 to 1.2 gigawatts. So it's like you have two different outputs. How can you change the numbers or give it so that they're on comparable fields? So engineering economics only really begins after the alternatives have been identified. So you're not coming up with the alternatives. You have a list of alternatives in front of you, and then you kind of pick through and see which ones are the best. So the analysis answers personal. Does that say answers? Okay, analysis answers personal, professional, and financial questions. Yeah, okay. So that does say answers. So when you go into the analysis, you're going to find out what they can be kind of done at different levels: personal levels, professional, and financial levels. And so real world situations often involve a lot of other factors that are kind of outside of the best alternative. So it's going to be some like what the cost, not necessarily like what can just produce the most amount of power, for example, but what's the cost going to be, and kind of being able to find the best balance. So frequently asked questions when it comes to engineering economics. So why do the project at all? Like why am I doing this? What's the point of what benefit am I gaining? So why do it now? What could I do it in 5 years? Would it be better for me to do it in 5 years? It depends on like what aspects you're kind of looking at. Why do it this way? Why do it in a specific way? Is this the optimal way? Is there another way that we can do it that will be a much more efficient way? And will the project create returns? Like if you're just going to, when you're making a project, you have to make sure it's feasible in the way that you can produce money. Because if you're going to do something and you lose money, it's not going to be beneficial for whoever makes it, and it won't be sustainable either. So an example of this, when you're kind of comparing side by side, is when you're comparing hydro and thermal thermal gas, and just two different sources of heat, right? So initially, hydro costs much more, but thermal is much less. So when it comes to hydro, the faraway load, I cannot read that. So the load's far away, so you're gonna have to. It costs money for transmitting the load, and so the thermal can be very near the load. So I think what that has to do is like the water is far away, and you have to bring it. Actually, scratch that. I'm just gonna leave that there. So hydro doesn't take any fuel, but thermal, you do need fuel. When you have hydro plant, it's gonna have a longer life as opposed to a much shorter life for thermal. And hydro plants don't create pollution, at least over the long term. It probably does when you're making it. And over the long term, thermal plants do create pollution. So which one do you choose? And it's a good question. Depends on whatever situation. It depends. That's the biggest thing that you're going to take away from all this. So continuing on with engineering economics. So when you're choosing to build a power station, whether it's nuclear, gas-fired, coal-fired power versus a wind farm or a CSP power plant, there's a bunch of factors you have to take in. So it's going to be the safety, the air pollution, public approval, which, funny enough, is a very large one, water demand, waste disposal, global warming, and other types of factors. There's a bunch more that you can get in there. So you're also going to include non-economical factors or issues in the decision-making process, and that's called multiple attribute analysis. So basically, a whole bunch of different criteria are involved when making the decision. So there's a bunch of different techniques that exist when it comes to making a decision. So when you're choosing the better alternative, you need to have an analysis conclusion. I think that's what I wanted to say. Needed for economic analysis conclusions. Okay. So I think basically what I was trying to say was essentially you need to choose an alternative. You can't just kind of say, well, I don't know. See, the whole point of having the economic analysis is that you put your recommendation forward as opposed to just, I don't know, you do with the numbers with your will. As someone who's doing engineering economics, that is your job to put the foot forward and say, hey, I think this is the best path forward. So when you're going through these analysis, you're going to have input from the government, politicians, special interest groups, public consultations, family, financial advisors, and so on. So when it comes to choosing better alternatives, the steps you need to take, so you need to define what are the alternatives in physical terms. So what are the options that we're dealing with here? So what's going to be the cost and the revenue estimates for each? So which ones, because maybe you're going to get in a situation where it's going to cost a lot of money to build, but you're going to make even more. So you have to evaluate which one's going to be the best for you. So, and then you also need to make all the money estimates comparable. Like I said earlier, it's not always going to be that clear on being comparable with like the different outputs. So put them on a level playing field. So what's the appropriate interest rate for, and then for how long you're going to be doing it, and then you recommend that alternative, which for the deciding factor, the people who are deciding it, so that it best fits their criteria, right? So when it comes to decision making, you want to break down complex problems into smaller ones so they're much easier to attack. So, and then create a significant solution. So once you break those down and you can pick them off, it's going to make life much easier. So knowing the process that you can do when it comes to decision making is going to lead to much better decisions. So you're not just kind of picking out of the air random things. You want a consistent, replicatable process which you can just make sure all of your answers make sense when comparing to other answers you made. So you don't have like one answer or recommendation that is completely different or doesn't follow the same sort of logic as the other one. Obviously, there's going to be different criteria when it comes to different projects, but you want to make sure that it's at least consistent in the way that you find it. So when it comes to simple problems, it's little to no organization and work required. With any luck, you see a simple problem, you just pick it off, get it done right away. When it comes to an intermediate problem, it's gonna require a lot of organization, and it needs to be analyzed. So you have to justify your thoughts and actions. Why are you making these actions? Why are you coming forward with this thing that you're gonna do, right? And so you have to back it up with either numbers or some sort of evidence behind it. So what are the significant economical aspects? But it doesn't have to just be economical aspects that you're focusing on. There's a whole bunch of different factors and aspects that you're going to worry about. So you have to assure an economic situation in equilibrium. So I'm not entirely sure what that meant. I think it's just you want to have it balanced so that it's able to not. You want balance. We'll just stick with balance. I think that's pretty good. So generally with intermediate problems, it's going to be a single criterion decision making. So it's going to be based upon one specific thing that you're able to put things up against each other and then just go bam, bam, bam. Easy as that. Complex problems. These are very tough. So they represent a mix of 4 elements. So economical, political, social, and environmental problems. Yeah, there's not really any hope that we're going to be covering these in these classes because, like, to be quite honest, they're the questions when it comes to like climate change that just kind of aren't like there's not really a clear answer for, or maybe there is and people just aren't listening. But it's not. Yeah, it's tough, much more difficult, but not something we're going into. So the process for decision making. You want to define your problem. What's the issue? Objectives and goals. What do you want to get out of this situation when it comes to solving the specific problem? So you want to gather all the data that you need to be able to make comparisons. Identify feasible alternatives. So what could be the best or possible other routes that you could take so that this could be the best alternative for the group. Choose the criterion that's best. Choose the criterion you're going to use to best determine what the best alternative is. I said best too many times, but that's all right. So then you're going to make a model and implement it, and then so you're going to predict the outcomes, which likely going to happen, which it's not always going to be very accurate, but you're going to do the best you can with those predictions. And then from those predictions, you're going to take the best alternative. You're going to audit your results. Make sure you've done things in a cohesive and clear way and you haven't made mistakes along the way. And so now going into macro versus microeconomics. So macroeconomics are based on whole economies. So as like economy aggregates, so it kind of covers like the export deficit, inflation. Inflation is basically how much poorer you are over the years. So how much with money's being printed every year. And if there's more money being printed, it's just my favorite example is the monkeys and bananas. If you have one banana is going to be rare. It's going to be valuable. But if you if you have 1 trillion bananas, each banana isn't going to be worth as much because it's very easy to find. It's in excess. It's in a large volume. So with more money being printed every year, and sometimes more than it should be, you're just going to be less and less rich. Your money can buy less every year, basically. And back to macroeconomics, it covers employment, the gross domestic product, and the workforce total. It also has to do with reallocation, income distribution in the country, fiscal policies by the government, and when it comes to how macroeconomics works, they kind of approach a top-down policy. So when you're having issues, you start with the global economy, and then it moves down to the local economy, whatever sector you're dealing with, the industry, all the way down to a specific business. And then when you go to microeconomics, this is based on like individual units or businesses. This is going to be like small companies. Think of like deliveries between like Ottawa and Toronto, and you don't really go that much farther than that. So this has to do with supply and demand. So, okay, so the idea behind this is basically supply and demand. So it's not necessarily to do with the global scale, but it can be like there's no limit to how big it can be because it's microeconomics, right? So anyways, supply and demand, it takes a bottom-up approach. So the goal is when you have micro and macro economics is so that they meet somewhere in the middle. So you start at the company and then you move up to the sector and then to the overall economy. And the goal with micro and macroeconomics is that they meet in the middle. And then the last thing we're going to talk about for today is aggregation. So it's when you combine individual markets into a single larger one. So why can we do this? It's a component of supply and demand. So it's important for the macroeconomical issues in different markets. So during fluctuations of markets, they kind of move up and down together, and these markets kind of depend on what they're connected to. I can't give you like a specific example off the top of my head, but it's like certain markets kind of rely on each other or relate to each other. And if one's not doing well, that one isn't going to work as well either, so it's going to go down. So when it comes to the system, there's no fully disconnected or fully connected, what was the word? I was going to say market we'll say market. So every market at least somewhat relies on each other. So if the market is going down or like the overall economy is going down, there isn't a market that can just not suffer from it at all because it's fully disconnected. Everything's connected in at least a bit of a way. So that is pretty much the coverage of the overall idea of the intro to economics from an engineering standpoint and micro and macroeconomics. And next week, we're going to be getting into supply and demand. So thank you all for watching, and I'll see you guys later.